Good afternoon, everyone. I hope you had a great lunch. First off, I would like to thank Albert Garcia and Cecil's for inviting me here today to speak. It's truly a pleasure to be here. As he mentioned, my name is Randy Duckworth, and I work for the U.S. Dry Bean Council. U.S. Dry Bean Council is a trade association that represents the growers, processors, and exporters of dry beans in the United States. We produce about 15 export varieties, and they're grown in about 20 states. And Jeannie Wharton is there in the back, our executive director. Welcome, Jeannie. Today I'm going to talk about some of the recent weather extremes that we've had over the past few years. Just about every day when you look at the newspaper, you see another weather disaster happening someplace. I'm going to look at the causes of those weather extremes, what's leading to what seems like a new weather disaster happening every week someplace. And then we're going to take a look at the future. What's the future for the world pulse industry? What's our long-term climate outlook in relation to weather extremes? And what can we expect that climate change is going to bring for the pulse industry in the future? And then finally, I'll share my conclusions with you. First off, let's talk about some of the recent weather extremes. And I say talk about, it's not a lot to talk about with them. They've happened, but it's kind of a trip down memory lane. This is a map of some of the extreme weather events that have happened in the world over the past couple of years. When I was first going to do this presentation, I looked at some of the weather extremes, and my first thought for a title was, "Why does God hate Australia?" But instead, I changed the title, and I noticed that there's actually weather extremes happening all over the place. The red triangles this is some of the extreme weather events we've seen over the past year in 2013. The red triangles represent extremely high temperatures, and the blue triangles represent cold anomalies, right? The year 2013 once again demonstrated the dramatic impacts of droughts, heat waves, floods, tropical cyclones on people and property throughout the planet. These are just some examples. This is in 2013, but some of the recent phenomenon we've had over the past few years. I'm sure everyone remembers with great fondness the U.S. drought of 2012. This is what we looked like in the United States in 2012, and this is the worst drought that we had had in 25 years. And it hit the United States particularly hard. About 80% of all the agricultural land experienced drought in the United States in 2012. And it damaged portions of all the major field crops in the Midwest, particularly corn and soybeans. And this led to, of course, an increase in farm prices for all these products, such as animal feed, which, of course, led to an increase in the price of meat. We fared a little bit better in the dry bean industry. We did experience drought through most of the regions of dry beans, but we were very fortunate to have very timely rains that we managed to pull in a decent crop when all was said and done, even though there was a lot of worry about that. The pea and lentil industry, as I recall, was not quite as fortunate as the bean industry, but they did get hit. This is Argentina just last year. I visited Argentina last year, and the picture on the right is a picture that I took of a field in the Salta region, and there was just nothing there to harvest, as you can see. What I recall when I remember that visit was just basically images of scorched fields, in many cases where there was complete crop damage. Total losses that were caused by that drought, which was the worst in 70 years, were estimated at over $600 million, primarily in the Salta and Jujuy regions there. Dry beans, along with soy, corn, peanuts, and chia, were the most severely damaged crops with average yield losses of 30%. And if you've looked at the price of white beans lately, you know exactly what the impact of that can be. An agroeconomist once told me, and I've noticed that this follows fairly accurately, for every 1% that supply and demand are out of equilibrium, there's a 5% difference in price. Now, it's not strictly linear, but if you take a look at prices over the long term, that tends to hold fairly true. It kind of goes like this, and when it gets really at the far end, let's say you're 10 or 15% out of whack, then it really starts climbing very high. Of course, there's a limit as to how much people are going to be willing to pay for anything. This is what Argentina's pulse exports look like this last year. And of course, the majority of what Argentina produces is dry beans. You see, it's hard to see it on here, but this is September 2012 right here. You see just under 60,000 tons shipped that month. This is September 2013, right around 10,000 tons. So 1 year difference, major shipping period for Argentina. Exports just dropped to the floor in Argentina. And as a result of that, you saw other white bean prices climb. As the international markets couldn't find Lubia beans, they started looking for other types of white beans from Egypt, from the United States. Great Northern beans sold out very early on. We even saw it go all the way down to navy beans in the United States. And we've seen markets that were traditionally taking Alubia beans, taking navy beans, because there's just nothing else to take. And you see what happened to the price. This is a price for U.S. Navy beans this year. Just went through the roof, and that's really all due to the drought that we experienced in Argentina some months back. This is Australia in 2013. 2013, at least according to what they say in the newspaper, was the hottest year on record in Argentina. It was incredible. I mean, if you looked at the news, even on CNN, I recall, you see pictures of dying cattle in various parts of Australia, crops that were just dying. It was a very, very tough year for agriculture in Australia. It was also a very tough year for the koala bears. This one just had enough of the heat, and he said, forget this, I'm moving to Canada. This is California right now, right? These are images. You see the comparison as you look at this, what it was, what it is now. It's pretty incredible. This drought first hit California hard in 2013, and it's continued on to the present day. It's been called the worst drought in centuries. I heard somebody on the news the other day saying it was the worst drought in 500 years. I don't know who was around then to give that comparison, but I would accept certainly that it's the worst drought in at least 100 years. They're figuring out ways to save their crops in California right now. And that's tough because they have a lot of crops like almond trees and fruit trees that you have to water or they just die. And so they don't have a lot of choices. And I think that's going to impact the pulse production in California because the guys just won't have a choice to plant that. They're going to have to use their limited water resources for their row crops, such as contracted tomatoes or their almond trees. California's municipal water system has announced that it can't even get the water to the farmers in many places this year. And that's going to be interesting for consumers in the United States because California produces over half of America's fruits, vegetables, and nuts. President Obama recently pledged $183 million in relief programs for that, for California. So that's the drought. Not every place, though, did they shut off the water. There's a lot of parts of the world where they had too much water. This is Minot, North Dakota, 2011. Doesn't look too good. If you have ever been to North Dakota, oops, sorry, I'm looking at the screen. You're not quite yet, are you? This is Minot, North Dakota. And if you've ever been to Minot, North Dakota, it looks Come on. We'll go back to that. It looks something like this. And that's taken from the air. I mean, North Dakota, if you've been there, is flat. And when they get rain, they tend to get a lot of it at once, and it doesn't have anywhere to go. And this is a good example. The Red River Valley is where, this area is where a big portion of the United States beans are grown, in this region with the red circle around that. And the Red River flows through that. And the Red River averages 5 inches of decline over the course of a mile on average through there. In many places, it's 1.5 inches. Essentially, it is a big, giant lake when they get a lot of water, because there's just no place for that water to go. There's not enough gravity. And so we see floods every single year in North Dakota. And this becomes more important as the weather changes, particularly in this zone. So you would think more water might be good for North Dakota, but not necessarily. Now, Australia, I was just saying, had the hottest year on record, right? They also had floods. They can't make up their mind what it's going to be, drought or floods. Certain parts of Australia experienced floods in 2013, but they also had one of the worst droughts in that country's history. Bangladesh, 2013. And if you know about Bangladesh, you know it's a very flat country, close to sea level, experiences very consistent flooding in there. India, 2013, 2014. India experienced flooding in 2013, had a very good monsoon season going into this crop, and then got hit by some very heavy rains just at the harvest time, which, if you've been following prices in India, certainly were reflected here in the past month or so. The reality that the crop didn't turn out as good as people expected. For 2014, this was mentioned earlier, the Indian Meteorological Division anticipates a below average monsoon season, and that raises the possibility of a drought, which could stoke inflation in this country, where only about half of the country lacks irrigation. Harbin, China, 2013. I was in Harbin last August. The picture on the left is a picture that I took there. The amount of rain that they got in a relatively short period of time was pretty amazing in that. What I think is interesting too about that, at the same time northeastern China was experiencing these torrential rains, southeastern China was experiencing a near record heat. These are what the crops look like in the field. Many of the places I visited, these are pictures I took when I was there. And this is what resulted from last year's crop. If you've tried to buy dark red kidney beans this year, you were shocked probably when each time you contacted your supplier, the price had gone up. Prices for Chinese dark red kidney beans, as I followed them this year, went up about $1,000 during this marketing year. And basically there's very, very little left at this point in terms of dark red kidney beans. Their black bean crop, of course, their white bean crop, their light speckled bean crop, most everything was affected pretty severely by the floods this year. Alberta, Canada. If anybody bought tickets to the Canadian Specialty Crops Association meeting or registered for that, you know what happened. This happened right before that meeting was supposed to take place. This didn't used to be waterfront property. It is now. So next, exciting part. So what's causing all these weather extremes? Anybody got a guess? Yes, indeed. Climate change. Yeah, I know it's a bit scary. It's a reality, unfortunately, facing agriculture, facing our industry. I would posit to you today, as do the vast majority of the world's climatologists, that climate change is in fact causing and increasing both the frequency and the number of extreme weather events around the world, particularly that are affecting our industry. Climate change is affecting today the world's pulse industry and agriculture in general. So let's take a look quickly at what is causing these changes in climate and why it's affecting the world pulse industry. You can't see it very well, but this chart really sums it all up. I say chart, it's actually like 4 charts in one. Here on the top, you see the global temperature trend. These are the anomalies in temperature. The second one, the top line is the land surface temperature, and the second line is sea surface temperature. And this is for the period between 1950 and 2013, right? Basically, the really important one is the second one, because the second one is the difference between the land surface temperature and the sea surface temperature. And when you get a big difference between the land surface temperature and the sea surface temperature, you get weather events. Basically, El Nino, La Nina, that's all about temperatures of the earth, the sea surface temperature, land surface temperature. And what you see as that deviation between those two has increased are weather events here at the bottom, and this is El Nino, because the worst events over the past few years have been mostly El Nino events, which are associated with warm weather, have increased both in frequency and intensity. You see the spikes are getting higher. You see the duration. If you look right here, the duration of the El Niños has been getting longer, right? So what's causing that? Why are land surfaces heating up? Why are the sea surfaces heating up? First off, it's carbon dioxide, and everybody's heard about this, greenhouse effects, right? If you look at this, if you look at the top, the intensity, it gets redder and redder as we go along here, okay? This is a 30-year period. It just keeps getting a little bit darker as the carbon dioxide levels over in our planet increase. And the vast majority of this information, just so you know, has come from, about 90% of the information that I have today has come from either NASA or the National Oceanic and Atmospheric Administration in the United States. So, if you don't like any of it, you can talk to the U.S. federal government. This is basically, everybody I think also knows about greenhouse effect, but this is basically what it is. So we've got the sun beating down, you get too much CO2 and it stops the heat from going back out and gets trapped in the atmosphere there on just above Earth, which increases the temperature, therefore increasing the land temperature and the temperature of the sea, right? What are the effects of that? Ocean acidification is one of them. So as you get more CO2 in the air, one of the ways that CO2 is dispersed is it goes into the ocean. About 25% of the CO2 right now ends up back in the ocean, okay? But what happens is that dissolved carbon dioxide combined with water forms carbolic acid, and carbolic acid prevents shell-type sea animals from forming a shell, including those that make up our reefs, right? And the reefs are really important to protect us from weather events. So if you happen to live in a coastal area, Bangladesh, and I don't really know actually whether they have reefs there, but the reefs protect them from these big wild weather events. What else do they do? All right, the reefs have all this fish life that we want. So if you want to eat sushi at the all-you-can-eat sushi bar, you better eat it now because prices are going to go up if the acid levels in our ocean keep rising as they have been. Okay, that's a reef. So the temperature of the Earth, it continues to rise right now. As you see in this closer chart, what's really particularly important when you look at this is this is 1880 here, basically the start of the industrial age, and things just kind of meander around. I mean, they're increasing at a fairly rapid rate. But once you get to 1970, you see it just goes, whoa, really starts rapidly increasing. And not coincidentally, the number of extreme weather events also starts increasing as the global temperature increases. So these are the mean average temperatures. I realize you can't see these. This is since 1996. Since the year 2000, 13 of the hottest weather events in recorded history have occurred since the year 2000. So in other words, since the year 2000, we keep getting hotter and hotter, right? So this is a look at just the January through March surface temperatures on the Earth. And you see 2014, so far the 7th warmest of 135 years. 2005, 5th warmest of 135 recorded years. 2010, 2nd warmest of 135 years. Land surface versus sea surface temperature. So as things start getting hotter, one of the things I think is really interesting about this is you look at what's happening with the ice, right? As this red increases, of course, the ice retreats, right? NASA has indicated that as a result of satellite observations, we have been losing basically Arctic ice at a rapid pace for the past 30 years. And this is what it looks like when you chart it out, okay? They basically do calculations as to how thick the ice is. And it's been on a downward trend since about 1978. But it's not all about the Arctic. Of course, you have the Antarctic. One of the things about there's a key difference between the Arctic and the Antarctic, though, that I think is worth noting. The Arctic is land-based, it's a continent, but the Antarctic ice is just sea ice that's over the ocean. So the Antarctic ice melts and reforms every year. And one of the things that's interesting is that actually, as the polar cap, the north, the Arctic is melting, the Antarctic is actually getting colder and forming more ice. Not at equal rates. It's melting more rapidly in the north than it's forming in the south, but it's still interesting how Mother Nature kind of balances things out a little bit sometimes. So this is anyway. That's the Antarctic, one particular part of it. Another thing that I think is really important as you look at surface temperatures, you look at the ocean, you look at the effects, is what's been the effect on snow. And this slide is an example of the northern hemisphere, what's happened with snow cover. And as you look at this goes through 2012, as you look at the snow cover anomalies, basically the amount of snow that we've been getting, at least through 2012, is going in the negative in terms of anomalies overall. Now I realize that some people are going to say, well, okay, you take the United States for example, and Washington D.C. they had like 35 winter snow events this winter. Global warming doesn't really strictly mean everything gets warmer. What it really means is that the extreme events become more extreme. So you might get actually cold events, snow events that are much worse, that get exacerbated as a result of it. It doesn't mean that it's always going to be a warmer event. This is ocean surface temperature. I just thought this was interesting because you can almost, as the green areas, if you look at the green areas and you see the sea surface temperature increasing, you also see that it corresponds to brown areas, which are, blue areas, which are a decrease in the amount of rainfall in those particular areas. So it's just a kind of interesting thing to look at. And it also corresponds to El Nino and La Nina, all right? So as I was mentioning earlier, El Nino is associated with warm water events. La Nina is associated with cold water events. El Nino has been the one we've been hearing from mostly over the past decade or so, but La Nina doesn't like to be forgotten. Again, this is some NASA imaging. I just thought it was interesting because you can see the polar jet stream, and you see basically kind of the heat patterns that happen. What happened there? All of this, what it adds up to, okay, when you get the increased surface temperature, the increased land temperature, is you have an increase in the amount of extreme weather events. And this is an example of the North Atlantic hurricane seasons. And if you overlaid this, which I didn't, but you could basically overlay it with some sort of measurement of the temperatures of the sea surface and the land surfaces, and you would find that you have an increase in, as the sea temperatures and the land temperatures increase, the number of events like hurricanes also is increased. And you see the intensity of, I've got to quit pointing at my screen for you to see it. The intensity, the number of hurricanes, at least in the North Atlantic region, has increased as the temperature has risen, right? So what's ahead for us? That's been up to the present. What's going to happen in the future? Well, there's a few things that we know. One is that the world population is going to increase pretty dramatically. I've seen numbers varying between 9 billion and 10 billion people. Most people settle on a number of around 9.5 billion. If you look at this right here, almost that entire increase is in developing countries. And this is really important for us as an industry because a lot of these are our buyers, right? Have pulses, India, of course, being the biggest one. And so we have to consider that as we look at how we're going to feed them in the future. The United Nations has estimated that we're going to need 70% more food. This was an estimation by another group who said we're going to need 69% more food calories, 69, 70%. Right in that range, that's how much food, that's the amount of food calories we're going to need, okay? But that does not equate to the amount of food actually that we're going to need, all right? And the reason it doesn't equate to the amount of food that we're going to have is because the middle class population as we move towards 2050 is expected, the number of middle class people is expected to increase dramatically in developing countries. So India, China, other parts of Asia are going to have big increases in the number of middle class people that they have, right? You've all heard this before. What happens as people get more income? They've been poor, they get more income, their diets change. They eat more meat. They eat more meat. So meat consumption is expected to increase dramatically. And in order to feed a cow or a sheep or a lamb or any other type of meat animal, you're going to have to feed it a grain or you're going to have to give it pasture land. And so that's why we're going to need basically double the amount of food to feed, to achieve 70% more caloric a value for the people, because there's going to be a big, huge increase, or at least that's what is forecasted. I got to catch up here. So, you know, what I would be asking if I was in the audience was, well, can't we just plant more, right? We've got land. There's a problem with that, in that even the undeveloped land, most of it is not acceptable for agriculture. It's either forest right now, high mountains, tundra, deserts. Agriculture is about 39% of the ice-free land right now. 39% cropland and pasture land, and the other approximately 15% is land that can't be converted to agriculture: rural housing, urban areas, mines, logging, planned timberland, that sort of thing. What we expect, of course, is that there is going to be more deforestation, and that's happening right now, particularly in places like Indonesia and Brazil, where the rates have been actually pretty astronomical in terms of how much land is being deforested. The upper left-hand corner is deforestation in Peru. Catch up on my slides, sorry. The one on the right is Indonesia. The number B, number C here with more purple is the United States, and then finally the last one is Russia. And the red represents deforestation. Embrapa, which is the Brazilian agricultural ministry recently came out with a study that said in order for Brazilian farmers to achieve the types of yield increases that they're going to need to maintain current production levels that they are going to need to achieve, they're going to have a 49% increase in yields in order to meet their future needs. It just doesn't seem possible given the increases, particularly with pulses that we've seen and have talked about before. This is the RLC on the border of Kazakhstan and Uzbekistan, and really I would put forward this as a cautionary tale about how dangerous it is sometimes to change ecosystems, even though you seem like we have a good plan for doing it. The Russian government diverted the RLC for other purposes, for irrigation and other areas. And the RLC, as a result, began shrinking in the 1960s. By the year 2009, it had lost more than 80% of its surface area, exposing roughly 50,000 kilometers of lake bed. That formerly thriving fishing industry associated with the RLC collapsed, of course, as the water became more saline, and the dried up seabeds produced giant dust storms. And then thousands of people were basically forced to abandon their homes in that area and move to other areas. So looking at sea ice for just a moment in the future, the predictions are that sea ice, that the Arctic could be nearly ice-free in the summer by the year 2035. And if that's ice-free, that means that the sea level, of course, is going to have to go up. Again, these are government predictions, not mine. I would be completely incapable of that sort of thing. This is what they're predicting to the year 2100. And these are different scenarios for how much sea level could rise. Basically, that band representing what they think is the lowest likely to the highest likely scenario for a sea level rise, with an average falling around right about 0.8 meters, 0.8 meters by 2100. Oops. By year 2050, and this is really not strictly linear, the general expectation is of a sea rise of about 6 to 16 inches. I have no idea how much that, actually I do have an idea how much that is in centimeters. So a range of 15 to 40 centimeters by the year 2050, rise in sea level. And a rise of 30 to 120 centimeters by the end of the century. Looking at water, by the year 2050, with an increased population, it's estimated that 52% of the population is going to be living in areas where there's a shortage of water, and 16% in areas where water supply is marginal or threatened. That's compared to 36% right now in shortage areas, 18% in marginal areas, and 46% in adequate areas. Now, where we have to really be concerned about that, as we see, is California is a great example of this. As demands on water become more intense, the fights between basically urban areas or residents and agriculture for water become more intense. And California is a perfect example of that. There are so many people battling over water in that state, it's just incredible. Here are the areas that are at risk of desertification under various climate change scenarios. And some other factors that we might want to consider as we look forward. This isn't really something that necessarily affects agriculture that I'm aware of, but the dust storm frequency as areas become more desert-like increase. This is a real issue in China. Right now, there's dust storms that blow in every year very frequently from the Gobi Desert in China into Beijing that cause huge problems. This is an example. In Seoul, Korea, these are a number of dust storms that have taken place over the last 40 years, and you see it's increasing. Another thing that surprised me as I was looking at this that we have to look at are what are the changes in insect populations. And this one kind of blew me away. Some people had done some modeling of under various scenarios what's going to happen, and they took kind of the average of the various scenarios for climate change and tried to map what they thought would be changes in insect populations as a result of those changes in the climate by the year 2050. And it's interesting, as certain areas get wetter, Russia, you see populations increasing. Other areas, not all of Africa is expected to get drier. Some parts will get wetter. But just interesting to look and see what the insect population changes would be like. A lot of predictions are that Canada and northern United States right there would get more water under in various climate change scenarios. So the insect populations would go up. That could have some interesting implications for us over the long term, because you take an area like North Dakota in the United States and they really don't have a pest problem because it is so cold. I mean, nothing survives there. I don't know how people survive. 50 below, it's crazy. And so as it warms up, are you going to have an issue with pea weevils in areas that you never had an issue with pea weevil before? Hopefully not, but it'll be something, an interesting thing to look at as we move forward. So what are the expected changes that are going to impact us in the pulse industry? I think one of the biggest things that we have to look at is basically the snowpack that's going to be available to us, because so many of our areas, particularly in North America, depend on snowpack for the water that we need to feed our crops and to feed our pulse crops. So particularly in the northern hemisphere, it's going to be, if it has a significant impact if climate change has a significant impact on snow cover, on the amount of snowpack, it's going to affect the water that's available to us. Come on. Again, water withdrawal and availability. Are we going to be fighting over water in different areas with an ever-increasing population? As the population increases, their water demands are going to increase, and at the same time, we're going to need more water to grow more food for that population. So we're going to kind of go head-to-head in some ways over water. This is an average of some of the yields that people have put out in terms of expected changes in yields in some of the countries in the year 2050, or regions. So Latin America and the Caribbean, down 9% overall. North America, up 1%. The big gain is actually Europe and Central Asia, up 7%, because Siberia basically, gets a lot warmer under a lot of these scenarios. New Zealand doesn't fare so well, and they've only got it down at 2.7%, but I'd say given recent weather, that's a pretty generous at only 2.7% down. This is, again, a chart on Africa's projected cereal yields going into the year 2080 and what they're going to look like. And mostly it's not good news, but Ethiopia in here is mostly, oops, again I'm pointing at mine, Ethiopia mostly unchanged. That's good in terms of the pulse industry. Looking at North America, because that's where I'm from, a little closer. These are scenarios that the National Oceanic and Atmospheric Association Administration came up with, A2, B1, they're kind of famous. 1, the United States gets very dry, gets very hot. On A2, on B1, it gets hotter but not as hot. Pretty simple, right? But at the same time, some areas get less water under this A2, the brown areas get less water. Really what's interesting to me, though, is that under both scenarios that they've come up with, the pulse-growing areas of the United States are going to get more water under their climate change models. There's going to be more precipitation under their models in the North American pulse industry, basically. So, conclusions, because I'm running out of time. One of the most dramatic things is the impact on sea levels. Come on, catch up. If sea levels raise even an additional meter, as many climatologists expect it to do this century, it would mean that the hurricane sea surges could increase up to 4 or 5 meters in some places. So get your surfboards. A meter, though, is really put someplace like Bangladesh in a precarious position. It's a very low-lying nation in terms of its relative to sea level, and it already experiences dramatic flooding, as do the Maldives. So a meter would have a huge impact. It would make many parts of Bangladesh basically uninhabitable. This is, the situation there now very frequently in Bangladesh. One of the other things that people talk about that often I don't think is given enough consideration is as the things get worse, particularly in the developing countries, you experience increased immigration. And we're already seeing a lot of this. If you live in Europe, you know this. There's a lot of immigration from Africa right now, illegal immigration to Europe. And that's only going to increase if the situation gets worse in these developing countries. So unfortunately, I didn't really have a lot of good news for you today. I think actually there's a lot of volatility ahead for us in the market. We're going to continue to have extreme weather events. There's going to be a lot of price volatility. If you're a company that likes that and trades on that volatility, well, you're in for a fun ride. If you're not and you want stability, well, you're probably in the wrong business. You know, I can't end things on a down note, so I do have a couple more positive predictions. I want to put a positive spin on this as we wrap up here today. And again, I'll take a look at North America and some of the likely changes. Canada, which is known for their curling and hockey teams, very famous for those, very good at it. They're also known for their polar bears, right? They're going to instead become famous for their new koala bears and their wine in Manitoba, right? And in Fargo, North Dakota, if you've ever visited Fargo in January or February, you recognize this picture. They're known for their really cold weather and their ice fishing. And what they're going to be known for in the future is their beach volleyball teams. It'll be great. You'll be vacationing in Fargo instead of Florida. Thank you very much. I really appreciate your time today. Just in closing, I would ask everyone here today, I hope you'll pitch in and help out on International Year of the Pulse on a personal level and on a financial level. It's the best thing that's happened to our industry. Thank you.